have data science first internal part B, which is similarity and dissimilarity in feedback. So this is our first question in which we have to compute dissimilarity between students' feedback profile described as this. So first is nominal attributes, that is method. First method, simple matching. So the formula we use is D I plus J is equals to P minus M by P, in which P is total number of variables and M is number of matches. So the logic we use is if values match, example both are CS, distance is 0, and if different, that means values are different, so the distance will be 1. Now, second, asymmetric binary attributes. So, in this, the method we use is Jacquard distance, which ignores negative matches. Formula we use is Dij is equals to R plus S upon Q plus R plus S, in which Q is both 1, that means yes, R is 1, and the other is 0, that is yes and no, and S is 1 is 0, and the other is 1, which is no and yes. We ignored cases where both students did not attend. So third, we have numeric attributes. The method we use is Euclidean and Manhattan distance. In this, we have normalization, which is crucial to normalize data. First, so large values do not dominate small values, that is CGPA 9.0. Fourth, we have term frequency vectors. Method we use is cosine dissimilarity. Formula we use is 1 minus cosine similarity. We measure the angle between vectors rather than distance, as document length shouldn't matter. Next question, we have in this question, we have given two student faculty interaction profiles in which we have to calculate the distances. So first, we have calculated the absolute distances. Here are the four absolute distances that we have calculated. Now we have to calculate more distances. So first A we have Euclidean distance, which is 6.708, Manhattan distance, which is 11, Minkowski distance, which is 6.15, and supremum distance, which is 6. Next question. Now, in this question, we have to analyze the complexity and suggest uh, the balance, accuracy versus efficiency. So, in this question, the problem is first finding the exact medium requires sorting the entire data set. So, complexity is sorting takes O n log n. For massive data, we cannot load everything into RAM to sort. Proposed methods. Histogram proposed methods are first histogram binding method, which divide range into beans, count items in each bean, estimate medium using interpolation, and the complexity is ON. Next, second is sampling, randomly select a subset of data and find its median. Heuristic, the median of a random sample is a good estimator of the population median. Heuristics for balance, that is accuracy versus efficiency. The Remedian algorithm is iteratively compute medians of small batches, efficient for streaming data. Containerizes data structures that store approximate rank information using very little memory. Next question, question number 8. So we have given a database, a data set of 5 students and a query x is equals to 1.4 and 1.6. So first we have to find rank existing student by similarity, and second normalize vectors to unit length and recompute. So the data set query X is 1.4 and 1.6. Students S1 is given 1.5 and 1.7, S2 given 2.0 and 1.9, S3 is given 1.6 and 1.8, S4 is given 1.2 and 1.5, and S5 is given 1.5 and 1. सो हमारा स्टेप ए है रैंक बाय यूक्लिडियन डिस्टेंस। तो हम पहले यूक्लिडियन डिस्टेंस S1 S4 से ले S1 S4 S3 S5 और S2 का कैलकुलेट करेंगे। उसके बाद हम अकॉर्डिंग टू दैट रैंकिंग करेंगे। So our ranking will be this. Now step B, unit length normalization. हमारा गोल क्या है? Scale vectors, so their length magnitude is 1. हम फॉर्मूला अप्लाई करेंगे। फॉर एग्जाम्पल हम S1 के लिए कर रहे हैं, तो उसका मैग्नीट्यूड एंड नॉर्मलाइज, देन वी परफॉर्म दिस फॉर ऑल द वेक्टर्स एंड द क्वेरी x एंड देन recalculate यूक्लिडियन डिस्टेंस। सो हमारे S1 का यूक्लिडियन डिस्टेंस आया है 0.66, 0.75।